Hi everyone, we're going to move on to 12.2 today. We are going to spend, I think, a total of 4 days in this section. We're still dealing with radicals. We'll still be working on simplifying, so if you struggled with that, we're going to continue with that. Today's date is the 28th, and our focus for today is going to be multiplying radicals, which we've done a little bit of this in 9.2. Like this problem should look familiar. First example should look familiar from 9.2. The rest of these we're going to use some distributive property to actually multiply the radicals together. Again, the most important part is knowing that if they're both under a root, you can multiply them. And if they are both outside of the root, you can also multiply them. But you can't multiply something that's outside and with something that's underneath. All right, let's go ahead and get started with our examples. So I have to multiply these two radicals together. And neither 2 or 12 is perfect on the power sheet, we know that at this point, but you can see it here as well. And so I'm just going to take the 2 times 12. I like to write it as one root first, under one root, under one radical symbol, rather than 2 separate. 2 times 12 is 24. Then I only have to worry about simplifying one radical rather than trying to simplify 2. And 24 is not perfect, so I'm going to ask myself, does 16 go into 24 evenly? The answer is no. Does 9? No. 9, 18, and then 27. And 4 does. 4 goes into 24 evenly. So I can write 24 as 4 times 6. One of these numbers has to be perfect. One of these numbers has to be on your power sheet. And 4 is perfect, so I know I want to use that. 6 is not. That's going to stay in the jail. When it comes out as something different. 4 comes out as what's across from it, a 2. So we have 2 that comes out and 6 that stays in jail. Perfect comes out, not perfect stays in. Second example. All right, we haven't seen any like this. I am multiplying this by this. Distribute means we're going to multiply. I have 5 times root 2. This is outside, this is under. I can't multiply the 2 and the 5 together, but I can show 5 times root 2. So 5 root 2 is what I get when I multiply these. This will hang outside, and this is still under. Now, root 2 times negative root 3. Let's just take care of the positive times a negative is a negative. And I hope you see that both of these are under a root, which means this is the case where we can actually multiply the two numbers together. 2 times 3, 6. Now, is 2 perfect? No. Is 6 perfect? No. Can 4 go into 6? No. And these are what we're going to call not like. We're subtracting, and they would have to be like radicals. These numbers would have to be the same in order for us to put these together. So we have 5 root 2 minus, and again, you can multiply the numbers that are outside, 1 and 1. So we could technically write this as 1 root 6, completely up to you. But we can't put these together again because they're not like. The radicands, these numbers would have to be the same. So we just leave our answer as 5 root 2 minus 1 root 2. Next example, I have to multiply this with this binomial. 2 terms here, 1 here. Again, I go to take the root 10 and distribute it with the 2. This isn't in jail, and this is. I still need to multiply them together, so I'm going to show that as 2 root 10. 2's got to stay outside the jail, 10 is underneath. Then root 10 times 5 root 5, and 5 is outside, being multiplied with a 1 that's technically out here. So 1 times 5 is 5, and 10 times 5 is 50. So I'm getting 5 root 50. Again, I'm going to check 10. 10 is not perfect. 9 doesn't go into it evenly. 4 doesn't go into it evenly. So 2 root 10 is going to stay 2 root 10. Now 50 is not on here, but as I work through my perfects, 49 won't go into it evenly, 36 won't go into it evenly, 25 does. So I'm going to keep the 2 root 10. I'm going to keep the plus the 5 outside, and I'm going to change this to 25 times 2. This is perfect. It's going to come out. When we bring it out, we have to multiply it with what's out there already. So we get 2 root 10 plus 5, that's outside, times, when we take out 25, it comes out as 5. So we have 5 times 5, and then we have the 2 still in jail. This comes out as something different. This does not, it stays in. These two numbers are both outside, and so we should multiply those. Sorry, my finger's in the way. Now, are these like? No, because this is a 10 and this is a 2. So we're going to go ahead and leave our answer like that. Okay. Remember that when you have a quantity squared, an exponent just means that you have the base twice. So I'm going to write 1 root 5 times 1 plus root 5. Sorry, I said 1 root 5, but I meant 1 plus root 5, which is the base. And I'm going to write that base twice. I have to multiply these, and I'm going to use the distributive property. 1 times 1, 1. 1 times root 5, 1 root 5. Now I'm done multiplying the 1 with everything that's over here. Now I'm going to take the root 5 times 1, and I'm going to take the root 5 times root 5. That might be something you want to show off to the side. Root 5 times root 5. And so we would get 5, they're both underneath. We can multiply those numbers. We get plus root 25. 5 times 5. So what I recognize, 5, not on your power sheet, can't simplify. 25 is on your power sheet, and it comes out as 5. So I have a 1 over here, 1 root 5, 1 root 5, plus 5. Perfect, comes out of jail, no jail there. I'm seeing some like terms here. These are like. 1 plus 5 is 6. I'm also recognizing that these are like. See how the radicands are the same? So we can add the 1's outside, keep the like part, and just add the 1's. 1 plus 1 is 2 root 5. 6 plus 2 root 5 is your final answer. These are not like. You can't put the 6 and 2 together. A lot of students will want to do that, but they're not like. This would have to have a root 5 in order to put those together. Last and final example. I have to distribute. I have to multiply. See nothing here. That tells me I'm multiplying. Root 2 times negative root 2. So I have a negative, and then they're both under, so I could take the 2 times 2 to get root 4. Negative root 4. Root 2 times 1 is 1 root 2. Negative 3 times negative root 2 is positive 3 root 2. Negative 3 times 1 is a negative 3. 2, not perfect. 4 is perfect. 4 comes out as 2. So this is going to come out as a negative 2. 2 comes out, there's a 1 here. Negative 1 times the 2 that comes out would give you a negative 2. Going to bring down my 1 root 2 and my 3 root 2 and my minus 3. Again, I can see that these two are like constants. Negative 2 and negative 3 is a negative 5. I also can see that these are like because they both have a root 2. We keep the root 2 part and we look at the numbers in front. Same signs, add and keep, you get 4 root 2. Now you can't put these together because this does not have that root 2. They're not like. Final answer will stay like that. Have a great day, everyone.